5.2 practice. We have this El Dorado Community College considers a student to be full-time if they're taking between 12 and 18 credits, units. The tuition charge is $50 per unit. Suppose we choose a full-time student at random. T is going to be the tuition charge for that student. So, make a histogram of the following distributions. So if they take 12 classes, 12 times 5 would be $600. 13, 14, 15, 16, 17, or 18 credits, right? 18 times 50 would be $900, okay? So, 12 credits happen 25% of the time, 13, 14, 15, 16, 17, 18. Okay, now, notice the higher percentages here, here, and here. Why is that? Okay, so the reason is because in college, most of your classes that you will take are 3-credit classes. So unit divided by 3, 12 divided by 3. If you're taking 4 classes a semester, that happens with 25% of the people. 5 classes, 5 times 3 is 15, right? So that'd be 30% of the people. And 18 credits is 6 classes, would be 15% of the people. Now sometimes you have some 2-credit or 1-credit classes that don't meet as often, but most of the time they're 3-credit classes. But anyway, that's beside the point. Make a histogram and describe its shape. Okay, so in our histogram, we have 600, we have 650, 700, etc. And then our probabilities have to go up to 30. So I'll just go 10, 20, and 30. Okay, and then you want to put them in. This happened 25%. Okay, I'll continue it and label it. Okay, so I labeled the rest of those there. 650 happened 10% of the time. 700 was 5% of the time. 30% of the time. 800 was 10%. 850 5%. And 900 15%. Okay, so there's your histogram. When you're in college, I would suggest you take your core classes, take like 15 credits, and then take one class that you really enjoy. If you really enjoy sports or activity, take one of those. If you take an art class, something like that, just take something you enjoy as well. Okay, describe its shape. Fairly symmetrical. Okay, so it's not like a bell curve necessarily, but we have a peak in the middle and we have two peaks on the side there as well. So it's fairly symmetrical. Okay, number 2 asks us to find the mean of this T, mean of tuition. So remember how we take the 600 times the 0.25 plus the 650 times 10%, right? We just keep going, this times this times this. Okay, so we will have that idea there, that times that, right, all the way through. And I'll pause the video and calculate that. Okay, I calculated all this and I got $732.50. Okay, then interpreting it, if many students are selected, their average tuition would be about $732.50. Okay, number 3 asks us to find the standard deviation of the tuition. Okay, so that means we got to take the square root of a bunch of numbers here, right? So the first one was 600 minus the mean squared, okay, minus the mean squared times probability. I gotta do that with every single one then. Okay, so 650 minus the 732.50 squared, and that one was 10%. And that was 5%. I'll keep going on the next line. Seven 32.50 squared times 750 was 30%. And 800 was 10%. $850 was 5%. And the last one was 15%. Okay, so it's the square root of that whole thing. And I will pause this and calculate that. Alright, so in putting this in the calculator, it's easy to mess up, but it should get, make sure you show your work and everything, you should get $102.80. Okay, so if we interpret that then, it says randomly selected student tuition would typically differ from the mean which was 732.5 by about $102.80. Okay, and the last one we have here, number 4. Owning versus renting. Not sure what your family does, but owning versus renting a home. Number of rooms in there. So do you rent? How do rented house units differ from people that own their house? Here's a distribution of number of rooms for an owner-occupied versus renter-occupied in San Jose, California. So just looking at San Jose, California's data. So number of rooms, a one-room apartment, 2 rooms, 3 rooms, 4 rooms, 5, 6, 7, 8, 9, and 10 rooms. Okay, big house, about 3.5% of owned people have 10 rooms, less than 1%, 0.3% of rented. Okay, so renters generally have less house rooms in the house than what owners do. Okay, so first thing we want to do is identify. It says X is the number of rooms and owners, and Y is the number of rooms and renters. Okay, so we're going to make a histogram to compare the two. So we're going to make 2 histograms, one for X and one for Y. Okay, and it went from 1 to 10 rooms. And then probability is, what's the highest probability in here? 30, looks like 36%. So we'll go up to Okay, so for X, the owners, 1 was like point very low. Also 2 is very low. 3 was point 2, so those are all very low. Okay, now starting at 4 rooms, this goes up to about 10%. 5 rooms, 21%. 6 rooms, 22%. They should be connected there. 7 rooms, a little less than 20%. 8 rooms, about 15. 9 rooms, about 5. And 10 rooms, about 3. Okay, now we're going to do the same thing for Y. For the Y is the renters. 1 room, very, very low. 2 rooms, a little bit more. 3 rooms, okay, so 3 rooms goes up to almost 30%. 4 rooms, 36%. 5 rooms, 16. 6 was about 9. 7, 3, 8, 1, and 9. Yeah, so those are almost not even existent there. Okay, so there's our histograms. Describe any differences you observed. Okay, so any differences. So notice the X is the owned, and this is the rented. Okay, so notice the centers. Okay, so if we go through socks, might as well go through and describe them all. This one here, fairly symmetrical. This one's more skewed right. Okay, more skewed right. If anything, you could say maybe this was, yeah, it's fairly symmetrical, we'll say. Outliers, not really. Centers, center here is maybe about 5 or 6. Center here would be about 3 or 4. The spread, this is more spread. Okay, looking at that distribution, and this is a little less spread. Okay, so yeah, so that's how we can describe that distribution. Okay, so for part B, find the expected number of rooms for each. So expected number is your mean. So you want to find the mean of X and then also the mean of Y. Okay, so we're going to find the mean of both of those. I'm going to pause and, okay, for find the mean, just to remember. Remember, you take this times the probability, okay, for enters. So we would take 1 times 0.003 plus 2 times 0.002 plus 3 times 0.023. Okay, so we're going to keep doing that just for the owners. Put 104. Okay, I'm going to pause and work that out here. Okay, so I put it in there. I got this as my mean. So the mean number of houses, number of rooms, and somebody owns the house, was 6.284 rooms. Okay, now we want to do the same thing for the renting unit, people that rent. So we're going to do 1 times this, 2 times that, 3 times this, 4 times this. Okay, so we're going to work those out there. Okay, so you're going to write that all out. The mean of Y, the renters, 1 times the probability plus 2 times the probability, 3 probability, all the way out to 10 times its probability. Then you want to work this out. Okay, I just put that in the calculator and I got 4.187 rooms. Okay, so explain why this makes sense. Okay, so notice this was higher, this is lower, and we noticed that here, didn't we? We noticed this one was going to be higher. We said it was 6.2. I said it was 5 or 6. 6.2 be up here more, and 4 point something, and we said it was 3 or 4. You know, right a bit above 4. Okay, so why does this make sense? People that own generally live in larger houses. Okay, and then part C says the standard deviations. It says the standard deviation of x is equal to 1.640, and the standard deviation of y is equal to 1.308. Explain why this makes sense. Okay, so looking at this over here, we said x was more spread out and y was less spread out, right? So from the histogram, we saw that x was more spread out, therefore having a higher standard deviation. Whoop, couldn't see that. So from the histogram, we saw that x was more spread out, therefore having a higher standard deviation, right? X has a higher standard deviation. X, we said, was more spread out than what y is. Okay, if you have questions, please come to class with them.